Okay, these are some just helpful hints for acid bases, practice number 1, starting at example or problem number 6. So you need to be on the second page. Here is problem number 6. So each of the next couple slides are going to talk about 6, 7, 8, 9, and just 6 through 9. 6 through 9 is what this set of notes will talk about, just to give you some hints. So let me switch over to my other program. So here we have, I've just copied and pasted example 6. So it says find the pH and the pOH of solutions with the following H+. Classify each as acidic or basic. So all of these values, A, B, C, and D, these are 4 separate calculations that you'll do. And for each of these 4, you will calculate the pH and the pOH and then tell me if it's acidic or basic. It would be very helpful if, when you tell me if it's acidic or basic, very helpful to you if you can justify how. So what I'm saying to you is that all of these values here represent the H+ concentration. So you are going to have to figure out how to do pH and pOH. I'm going to give you an example not like these 4, but another example here for you to work through. And then you will do these 4 examples on your homework packet. So let's say that I have, we'll just, for purposes of simplicity, we're going to call it, when I get my pen working again here, we're going to call it example E. My goodness, let's try this again. I don't know what this thing is doing, but it is doing something funky. Let me see if I can get it fixed. Okay, as I was trying to explain, I figured out fix my pen here. We're going to pretend like we're doing a 6E. So 6E, let's say I gave you 4.77 times 10 to the negative third. Let's just do that. Okay, so 4.77, these are 2.7. So how you would do this problem is you'd have to show your formulas, and we know that based on this question, this equals H+, because what I'm telling you in this question by stating this piece, that each of these represent the H+. So I could see this being here, I could say H+ equals H+ equals, and H+ equals those values. So if this was your example, right, here's what you would do. You would say that H+ concentration can be found. I'm starting out this the wrong way. Let me try this again. We need to solve for pH. So we know pH is equal to the negative log. So you need to show the basic formula every single time, all 4 of these. So negative log of, in my example, 4.77 times 10 to the negative third. Let me clean this up a bit. And then so we're going to grab our calculators and say 4.77 10 to the negative 3. So that's EX button, or the times 10 button, or the EE button. So EXP button, the EE button, or the times 10 to the N button. And I get a pH of 2.32. So that's the first part, and you can show your work here, or you can put it on another sheet of paper, preferably here, so you have some space going across here on your actual piece of paper. And then I can figure out pOH by saying 14.00 equals pH plus pOH. So then I can say 14, yes, you need to write the generic formula each time. This gets you in a habit of knowing what it is. 2.32 plus pOH. To solve this for pOH, I'm going to take 14 minus, because it's being added and subtracted, 2.32. So pOH is equal to 11.68. You're going to circle this answer. You're going to circle your pH answer. And then you're going to tell me if it's acidic or basic, and then why. So you could say that this is an acid or acidic, and you could say because pH is less than 7. I'm going to use a different color with a little bit thicker marker just so you can see that. This is pH is greater than 7. So this is what you're going to do on your paper for parts A, parts B, part 6C, and part 6D. So you have 4 of these problems that you're going to practice this skill over here that I did with. And you're going to circle your pH, circle your pOH, and then write a statement that tells me it's acidic or basic and why. So I hope you listen to the video so that you can understand all these pieces. Okay, so here is what you should get for answers, but you must show your work as I'm showing here. Again, you must give me the generic formula that you're using or formulas that you're using, and then an answer with work. This is what you should get for all 4 of those pieces. These are your answers you should get for that. Okay, looking at 7, it says calculate H plus and OH minus with the following pH. So then these are all pH. So this is pH equals, pH equals, pH equals, and pH equals. I'm going to do an example here. Let's say you have a pH of 5.39. So here's how you would follow through with this problem. I need to get H plus and OH minus. I know that H plus can be found by taking 10 to the negative pH. That's what the antilog means in your notes. We wrote out the word antilog. This is the antilog, or the opposite function, or sometimes referred to as inverse function. So 10 to the negative 5.39. You're going to hit the second function of the log button. So I'm going to put in 5.39 or negative 5.39, depending on how your calculator makes you put it in. And then I'm going to hit second log, and I'm going to get that in scientific. So either move your decimal or know how to use your calculator. This is going to be equal 4.07, I'm ignoring sig figs, times 10 to the negative 6, big M. And now I need OH minus concentration. So to do that, we have to do one of 2 things to get the other value. We could do pH equals, I keep doing that. We don't want to start with pH equals, I apologize. We want to start with 1400 equals pH plus pOH. We knew that pH in my example, so 14.00 minus 5.39 plus pOH. So this is one method. There's going to be 2 ways you can do this, and you don't have to do both. You just have to do one or the other. So then pOH, what did I do? I took 14 minus 5.39, and I got 8.61. And then I can continue on with this problem. Give me just a moment to try to navigate the program so I can get some more screen here. So then I can say OH minus concentration is equal to 10 to the negative pOH. That's the formula I'm using. So this is going to be 10 to the negative 8.61. So we can do 8.61 negative, or negative 8.61 depending on your calculator, and then second log. So this is going to be 2.45 times 10 to the negative 9th. And now if you look at the top of that's my OH minus concentration. Remember I said there was 2 ways. I was going to show you both ways. So that I've now answered both these questions. I've calculated both of these pieces. Now another way that we could have done this, I'm going to change colors. Okay, another way we could have done this is we could have said 1.0, hold on, that's just too thick. It's going to be too hard to read my messy handwriting. 1.0 times 10 to the negative 14 equals H plus concentration times OH minus concentration. And you are going to do then 1.0 times 10 to the negative 14th. We're going to go back up and grab our OH minus concentration, 407 to the negative 6. I misspoke. This is our H plus concentration here, not our OH minus. This is our H plus concentration, 407 to the negative 6. So I'm going to bring that down and plug it underneath here. Sorry, I already forgot what it was. 4.07 to the negative 6. Okay. It is 4.07 times 10 to the negative 6 times OH minus. So we're going to take 4.07 to the, let's try that again. 1.0 to the 14th negative, divide by 4.07 to the 6th negative, and I get OH minus concentration to be 2.45 times 10 to the negative 9th, which you can see that both of these answers are comparable. I think this ended up rounding to 2.46, and that's just because of where we chunk things off throughout. So close enough. What I care about is the exponent's the same, and it's nearly the same value. So that being off by 0.01 is not a big deal to me. Now, you can see that the blue way was shorter than the red way, but either method would be sufficient and okay to do. I don't care which method you use. If you can do both, the better off you are. So now you are going to do that for these problems, and you should get these answers. For example 7. Okay, for example 8, I gave you two solutions, solution X and solution Y. I gave you the pH of one and the OH concentration of the other. You need to show me with a calculation which one is more basic, and with a calculation which one has the higher OH minus concentration. I do not care which method you use, but you are going to need to problem solve through something that you can compare. So, when we talk about something being more basic, there are a couple ways that we could be looking at that. We could be looking at the fact that the pH is greater than 7. You could use that method. You could say that the pOH is less than 7. You could say that H plus concentration is less than OH minus concentration. Or you could say OH minus concentration is greater than H plus concentration. All of these four methods right here identify something being more basic. So you have to take solution X and solution Y and the pieces that I give you and figure out a way to either compare both of their pHs, both of their pOHs, their H plus to OH minus concentration, either direction to do that. One more time. You're going to take the value you have for X, you have pH, and you have Y given an OH minus. You got to get both of these to the same thing, and either one of these circumstances you could use to prove whether it was basic. And therefore, you could use either one of the circumstances to show which solution has a higher pOH. So you're going to use this information here in blue and the given values here and here to answer this question. This is what you should get with proof. You can't just tell me Y and X without any work. I will not give you credit for that. You have to show the work and justify your answers based on the values you get. Again, you'll either compare the pH of X to the pH of Y, the pOH of X to the pOH of Y, or the H plus of X and Y compared to the OH minus of X and Y. Either direction can be done, and you need to do whatever you need to do to answer both. So I say that in that way because it could be definitely several different directions you can go to approach that. You pick what method you want, and you should be able to show, once again, that the first answer is Y and the second answer is X. So, for example 9, this is very similar to what we just did. You're given the pH of solution A. It tells you that solution B has H plus 3 times that of solution A. So you will need to get the H plus concentration from here to be able to multiply it by 3 for solution B. So you're going to figure out the H plus concentration of solution A, and then you know that the solution B is 3 times that value, and then solution C has a pH that's half of solution A. So you can actually already figure out the pH of solution C by taking half of 12.32. So you're going to navigate through those pieces in the relationships that's given here, and you're going to figure out the H plus for all three concentrations. So you're going to show your work and tell me the H value for A, the H plus value for solution B, and the H plus value for solution C. You're going to do that in the space provided on your worksheet. Then you're going to tell me the pH of solution B, then the pH of solution C. And then you're going to tell me for each solution if they're acidic or basic, and you're going to justify. So remember, the way you can justify things is that you can tell me, you can compare pHs to tell me if it's acidic or basic. You can compare POHs to tell me if it's acidic or basic. You can compare H plus to OH minus. So you can compare whether these, how are those greater than or equal than. So again, to figure out if something is acidic or a base, you can say pH versus greater than or less than 7. You can talk about if something is acidic or basic if it has a POH greater than or less than 7. And then you can compare whether H plus is greater than or less than OH minus. So these three methods are the ways that you can justify whether it's acidic. So I want you to justify for A, B, and C, and I also want you to tell me if it is acidic, or if it's a basic, or if it's a neutral. You will do that by justifying using the pH pathway to justify pH to pH, or pH greater than 7 or less than 7, I should say, and POH, whether it's greater than or less than 7, you can use that to justify whether it's acidic or basic, and you can use the fact that you could compare H plus to OH minus. So one more time, let me be clear, because I think I want to make sure I'm speaking clearly. To justify whether something is an acid, a base, or a neutral, you can talk about its pH being greater than or less than 7. And if you don't know what that means or which direction to go, look in your notes. You could talk about the POH being greater than or less than 7 to justify if it's an acidic, basic, or neutral. Technically, I should say pH greater than, less than, or equal to 7. A POH greater than or less than or equal to 7 could justify whether or not something is an acidic, a basic, or a neutral. And then a H plus versus OH minus concentration could be a way of justifying whether the solutions A, B, and C are acidic, basic, or neutral. This is what you should get for your answers, but you will need to be able to do mathematically and justify for part D why things came out the way they are. Have a great rest of your afternoon. Thank you very much.